Okay guys, we're going to continue our expressing the functions in the form f of x equals x minus k times q of x plus r of x, our quotient and remainder from division using synthetic division. So for k equals -2 goes outside. 1, 4, 5, 2, no missing terms this time. 1 comes down, 1 times -2, -2, add going down, it's 2. 2 times our outside number, -2, is -4. Add going down to get 1. 1 times -2 is -2. Add this to get 0. So that means I can express this function as f of x equals x plus 2 times, it looks like x squared plus 2x plus 1. With no remainder, so there's no plus on this one, unlike the last one. Because there's no remainder, this actually means that this was a factor. One thing we know about factors, or zeros of a polynomial, is when you plug them in, you should get 0. Since there's no remainder hanging off here, if I plug in -2, this whole thing's 0. 0 times anything is 0, and there's no adding anything on. If I were to plug in -1 to the one from the last video, we would get 0 times something, which is 0, but there's this plus 3 hanging on in the end, so the answer would be 3. So generally speaking, you can use synthetic division instead of plugging in numbers to find f of something, which is a useful tool. Okay, so lastly, one more. 3 goes on the outside. We're missing a constant term here, so we need to bring a 0 down at the end. So 4, -3, -20, -1, 0. 4 comes down, 4 times 3 is 12. Add to get 9. 9 times 3 is 27. Add to get 7. 7 times 3 is 21. Add to get 20. 20 times 3 is 60. Add to get 60. So what is my function here? It's x minus 3 times 4x cubed plus 9x squared plus 7x plus 20. And then of course my remainder is added on after the parentheses. Okay, so why is this useful? We'd like to be able to know factors without plugging things in. So we have the remainder theorem. If a polynomial is divided by x minus k, the remainder is equal to f of k. So that remainder we get at the end is the equal value to if we plugged in the number. So we go 2 on the outside, 1, 5, and 6 on the inside. Bring down to 1. 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. 6 plus 14 is 20. This tells me that f of 2 is 20. Now I can check that if I wanted to plug it in. Is 2 squared plus 5 times 2 plus 6, 20? That's 4 plus 10 plus 6. It is equal to 20. So this could be a potential way that you find out the value of something by plugging it in without having to actually plug it in. For us in particular, in 3.3, we're going to start factoring large polynomials, and we're going to use this to find zeros. -1, 2, -3, -5, 4. 2 times -1 is -2. That makes -5. -5 times -1 is +5. So then when I add these, I get 0. 0 times -1 is 0. So the 4 just going to come down when we add. So again, that means f of -1 equals 4, because that's our remainder. And of course, we can do this with fractions. 1/2 on the outside, 1, 6, 9, 3, -3 on the inside. 1 comes down. 1 times 1/2 is 1/2. 6 plus 1/2, that's 12/2 plus 1/2 is 13/2. 13/2 times 1/2 is 13/4. So this is 36 fourths plus 13 fourths is 49 fourths. 49 fourths times 1/2 is 49 eighths. 3 is 24 eighths. So when I add them, I get 73 eighths. 73 eighths times 1/2 is 73 sixteenths. This is a negative 48 over 16, so that makes it 25 sixteenths. That means f of 1/2 is 25 sixteenths. So this is how the process works. It works with any kind of number when you're just plugging in a value. Now, we can use this to see whether or not something is a zero of a polynomial. If a polynomial has a factor, we know that the rule is if you plug in that number, the factor, you get 0. That means when you are dividing by the factor using synthetic division, you should have no remainder. So let's see how this works. If 2 is a factor, then at the end, I should get a 0 for the remainder. 1 times 2 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 2 is negative 2. 4 plus negative 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So what does that mean? That means 2 is a 0 of x cubed minus 3x squared plus 4x minus 4. And I could factor it out. That means x minus 2 is a factor, and that the remaining factor are my remaining terms. X squared minus x plus 2 would be what's left. So I can keep going. I'm going to leave number 2. Let's do the one where it asks for the fraction, negative 3/2. 4. There's a missing x cubed term. Keep that in mind. 4 comes down. 4. 4 times negative 3/2. 4 divided by 2 is 2. Times negative 3 is negative 6. Add here to get negative 6. Negative 6 times negative 3/2 is 18 over 2, which is 9. Gives me 10. 10 times negative 3/2 is negative 15. That gives me 2. 2 times negative 3/2 is negative 3. Gives me 0. So that means it is a 0. If I were to write down its factored form, technically this would be x plus 3/2 times 4x cubed minus 6x squared plus 10x plus 2. Now, one last thing of note that I want to talk about is your homework is going to have you test this with factors like I. So let's say they wanted to know if factors of x squared plus 2x plus 5, they want to know if 1 plus 2 or negative 1 plus 2i is a factor of this thing. It works the same. You still bring down your coefficients. Bring 1 down. 1 times negative 1 plus 2i is negative 1 plus 2i. When I'm adding this, 2 plus negative 1 is 1. 0 plus 2i is 2i. Unfortunately now, 1 plus 2i, I'm going to have to multiply it by the outside. So 1 plus 2i times negative 1 plus 2i. 1 times negative 1, negative 1. 1 times 2i, 2i. 2i times negative 1 minus 2i, and 2i times 2i is plus 4i squared. And notice my middle terms cancel, so it's negative 1 plus 4i squared. Remember that I squared turns into negative 1. So this 4 times negative 1 is really negative 4. Negative 1 times minus negative 4 is negative 5. So every other time, your i's may end up canceling eventually. 5 plus negative 5 is 0. Well, guess what? The same strategy still holds. Since I've got zeros for remainder, that means negative 1 plus 2i is a factor of x squared plus 2x plus 5. And it would factor into x plus 1 plus 2i. But anyway, that's just how it works in case you have to deal with the imaginary numbers. And that is all for 3.2.